Hi, my name is Muhammad Indra. I will be presenting the solution for question 1A of our mathematical economics assignment. In this problem, we are given a cubic function and our goal is to identify the interval where the function is increasing or decreasing using a sign diagram. Given fx equal 2x cubed minus 9x squared plus 12x minus 4. The first step is to find the first derivative, fx. This tells us the slope of the function. By applying the power rule of derivative, we will get fx equals 6x squared minus 18x plus 12. Next, we need to find the critical point. This occurs where the slope is 0, meaning fx equals 0. So we need to factorize fx equal 6x squared minus 18x plus 12, and we will get 3x minus 2 x minus 1 equals 0. Therefore, our interval point, our critical point are at x equal 1 and x equal 2. Now, let's look at the sign diagram, which is essential to support our conclusion. 1. For the interval negative infinity 1, if we test a value like x equals 0, fx is positive. This means the function is increasing. For the interval 1, 2, if we test x equal 1.5, we get a negative value. This indicates the function is decreasing. For the interval 2 infinity, if we test x equal 3, the value is positive again. So the function returns to increasing. In conclusion, the function fx is increasing on the interval negative infinity 1 and 2 infinity. Next, the function fx is decreasing on the interval 1, 2.
Assalamualaikum, my name is Muhammad Mukri bin Hamizan and I'm gonna explain question 1b. The question given, a firm faces the following demand function, which is PQ equal to 100 minus 4Q. Question 1. Derive the total revenue function R times Q. Since the price depends on quantity and is given by PQ equal to 100 minus 4Q, we substitute the price into the revenue formula. Total revenue equal to price times quantity. So RQ equal to 100 minus 4Q times Q. Then we multiply this out, we get RQ equal to 100 Q minus 4Q square. For question 2, determine the concavity of the revenue function. To find whether the revenue function is concave upward or concave downward, we look at its second derivative. First, we take the first derivative of the revenue function to see how revenue change with quantity. First, R prime Q equal to 100 minus 8Q. Then we differentiate, then we get negative 8. Because the second derivative is negative, the revenue function is concave downward. For question number 3, find the output level at which total revenue is maximized and interpret the result economically. To find the output level that maximizes total revenue, we take the first derivative of the revenue function and set it equal to 0. This is because total revenue reach a maximum at a turning point. We set marginal revenue equal to 0, and this 100 minus 8Q equal to 0. And then negative 8Q equal to negative 100. Then Q equal to negative 100 divided by negative 8, we can get the total Q equal to 12.5 units. Total revenue is maximized at 12.5 units, where the marginal revenue equal to 0.
Hi, I'm Lam Yufei and I'm here for answering question 2. The total cost for a company is given by the equation total cost equals 100 plus 2Q plus 0.1 Q squared, where the Q is the quantity of unit produced. So to calculate the marginal cost for the company, First, we know that total cost is equals to cost times quantity, which we will use in the function. CQ equals 100 plus 2Q plus 0.1 Q squared. So by using the first derivative function, we can get C prime Q, which is the same thing as marginal cost. So with the first derivative function, we will get 2 plus 0.2Q. That's the marginal cost. For question number 2, we are required to determine if the marginal cost is increasing or decreasing as the production increases. With the marginal cost we calculated earlier, C prime Q equal to plus 0.2Q, we can use the second order condition, which is C double prime Qs, and we can get 0.2, which is just remove the Q from 0.2Q. And the final answer we can get is 0.2, is more than 0, which shows it's positive. And this means that marginal cost is increasing as the production increases.
Good morning, everyone. My name is Darshini, daughter of Subbarao. My metric number is 312521. Today, I will start presenting from question 2, part B1. The price function for a product is given by P equal to 100 e power of negative 0.05 Q, where P is the price per unit and Q is the quantity of output sold. Find the quantity that maximizes revenue. They are given the price function, which is P equal to 100 e power of negative 0.05 Q. Since revenue is price multiplied by quantity, the revenue function become RQ equal to 100 Q e power of negative 0.05 Q. In this case, the revenue function is a product of two different functions. One is 100Q and the other is e power of negative 0.05Q. Because of this, we cannot differentiate it directly. Therefore, we use the product rule. The product rule states that if RQ equal to GQ times HQ, then the derivative is R prime of Q equal to G prime of Q times HQ plus GQ times H prime of Q. Here we let GQ equal to 100Q and HQ equal to e power of negative 0.05Q. Differentiating each part, we get G prime of Q equal to 100 and H prime of Q equal to negative 0.05 e power of negative 0.05Q. After that, we need to substituting into the product rule formula. R prime of Q equal to 100 e power of negative 0.05 Q plus 100 Q in bracket negative 0.05 e power of negative 0.05 Q. After simplifying, we have R prime of Q equal to 100 e power of negative 0.05 Q in bracket 1 minus 0.05 Q. To find the maximum revenue, we set R prime of Q equal to 0. This gives 1 minus 0.05 Q equal to 0, so we get Q equal to 20. Therefore, total revenue is maximized when 20 units are sold. Next, part B2. Determine the intervals where total revenue is increasing and decreasing. We use the test point method to determine where the total revenue is increasing and decreasing. From part B1, the derivative of the revenue function is R prime of Q equal to 100 e power of negative 0.05 Q in bracket 1 minus 0.05 Q. We get the critical point, which is Q equal to 20. For test point method, we have to determine two intervals. First interval is Q between 0 and 20. Let's choose a test point, for example Q equal to 10. We need to substitute Q equal to 10 in revenue function, so we get 30.33. Since 10 is positive, total revenue is increasing in this interval. Next is interval 2, Q greater than 20. We choose 30 as a test point. We need to substitute Q equal to 30 in revenue function. So we get negative 11.16. Since 30 is negative, total revenue is decreasing in this interval. Therefore, total revenue is increasing when Q is between 0 and 20, while decreasing when Q is greater than 20. This confirms that revenue reached its maximum at Q equal to 20. Question 3. A local manufacturing company aims to maximize its profit. The company's demand function is Q minus 90 plus 2P equal to 0, while its average cost function is AC equal to Q square minus 8Q plus 57 plus 2 over Q. Find the value of Q for which the profit is maximized. For question 3, there are given a demand function and average cost function, and the objective is to find the quantity that maximizes profit. First, from the demand function q minus 90 plus 2p equal to 0, we rearrange it to express price in terms of quantity. This gives us p equal to 45 minus 0.5 q. Next, we calculate total revenue, which is price multiplied by quantity. So, RQ equal to 45 minus 0.5Q times Q, we get 45Q minus 0.5Q square. Then we find total cost by multiplying the average cost function by Q. This results in CQ equal to Q cube minus 8Q square plus 57Q plus 2. Profit is total revenue minus total cost. After simplifying, we obtain the profit function, which is PQ equal to negative Q cube plus 7.5Q square minus 12Q minus 2. To maximize profit, we take the first derivative and set it equal to 0. Solving the equation gives two critical points, which is Q equal to 1 and Q equal to 4. Question 3 number 2. Using the second order condition, prove that the quantity in 1 results in a maximum profit. Now that we have identified our critical points in previous step, we need to verify which of these quantities actually maximize our profit using the second order condition. First, let's look at our first derivative, which represents the marginal profit function. P prime of q equal to negative 3q square plus 15q minus 12. To find the second order condition, we take the derivative again. This gives us negative 6q plus 15. Now we have to test the critical points. We have two critical points, which is q equal to 4 and q equal to 1. For q equal to 4, when we substitute this into our second derivative, we get negative 9. Since this value is less than 0, which is negative, it confirms the function is concave downward at this point, also known as maximum profit. For q equal to 1, when we substitute in second derivative function, we get positive 9. Since this is greater than 0, which is positive, the function is concave upward, indicating a minimum profit. In conclusion, because the second derivative at q equal to 4 is negative, we have proven that the profit function is at its highest point. Therefore, to achieve maximum profit, the output must be exactly 4 units. Thank you.